Yeah, hello everyone. Myself Maruthi, welcoming you all to this math video session. In this video, I have taken a topic from trigonometry, and in the trigonometry, we have a separate category of sums that is nothing but eliminating the theta. Eliminating the theta. Theta is nothing but the angle. So angle is nothing but trigonometry. So here the question says is we don't want trigonometry, though it is there in the question. Simple answer. Eliminating the theta. Theta means angle. Remove trigonometry and get everything without trigonometry. That is the given question for us. If you check it out, so that is what? Eliminating the theta. What is the given question for us? Q tan theta plus P secant theta is equal to X. And the one more equation what he has given is P tan theta plus Q secant theta is equal to Y. He has given two equations for us. He is asking us to remove the theta. Theta is nothing but the angle. The angle means we don't want tan here, we don't want secant, we don't want tan, we don't want secant. You do anything with these two equations. These are the two equations. Right, you do anything but just remove all the trigonometry from there. That is what the concept says. Eliminate the theta. Okay, so while dealing with this one, right, as the question is in trigonometry, obviously we have to start from trigonometry, that is by taking the formulas present in the trigonometry. That's good. So what are the formulas? Generally, what are the formulas what we come across at the while dealing with such category of sums is nothing but square identities or multiplicative identities. Why did I choose only square identities or multiplicative identities? Means you can check it out. A trigonometry is becoming a number. A trigonometric formula is becoming a number. If you check it out, all these things, all the trigonometric values are converting into a number, means we are eliminating the theta. So that is what. So to eliminate theta from these two equations, set the question, take the help of these equations, either multiplicative or of course multiplicative identities are also called as reciprocal identities and the square identity. Of course, square identities, multiplicative identities, quotient identities, all these comes under fundamental identities. Okay, I'm cool. I'm thinking like this. Why can't I use square identities? Now one more question. Why am planning to use square identities only? Why? Because if you check it out, we are having plus in between the two here, the trig here, whereas here we are using multiplication. So my concept is, let's use what's that? Square identities. Now in that square identities also, which square identity we have to use? Is the first one which is dealing with sine and cos, the second one which is dealing with the secant and tan, and the third one which is dealing with cosecant and cot. Now let's observe the question. In which trig ratios the question is? Obviously the question is in terms of secant and tan. Now if you match it up, which trigonometry, which square identity is matching to the requirement? If you check it out, it's nothing but the second square identity, secant square theta minus tan square theta. Why? Because here we are having secant and tan, whereas we are having secant and tan in the question also. So my plan is cool. Let's take square identity, that to the second square identity. Now what is required? We have to match up the given question according to the formula. That's what. Now if we like to use that formula there, this equation should match up to that one. So what is that matching? What is that matching means? What is the power here? Square. Do you have that power here? No. So my thing is, I like to bring square here. Point 1. Point 2, right, we are having subtraction, secant square theta minus tan square theta. We have to make this subtracted. We have to bring that minus here. So that is what? That's the cool things. So let me trace out the track. Let me trace out the track for you. So what is the given question? Question, trig is there. Trig is present. Right, in the question, trig is present. In the answer, we don't know trig. That is the first logic. Point 1. So my thing is, there is a trig in the question, we don't want trig in the answer. Second one, use square identity 2. Which one? The square identity 2. Okay, right. Third one, we need power 2. That's odd. Why? Because we are having squares here. That is the third logic. The fourth logic is we need subtraction. That's cool. These are the four things what you have to keep in mind while dealing with that. Point 1. We have to remove the trig. Point 1. We are supposed to use square identity. Which one? Second square identity. Why? We are dealing with the secant sentence. Point 2. And the next one, we need the power 2. So to get to power 2, what is supposed to be done? Point 3. The next one, we need subtraction in that equation. So let's start working from there. So now let's go for that. So I like to call this is nothing but the given thing. Okay, I am taking this as given. I like to call this as equation 1 and I like to call this as equation 2. These are the two equations. So what to do? Let's go. So we are planning, but we have to set it. We are planning to use square identity. What we need? We need square. So how to get square there? So the only logic present there is squaring on both the sides. Let's take first equation and square it on both the sides. In the same way, let's take the second equation and squaring on both the sides. Let's do that. So squaring on both sides, squaring on both sides for equation 1. Okay, so what I am doing, I am taking equation 1, I am squaring on both the sides. So let's work on there. So squaring on both sides means whole square is equal to, we are having square. So I am taking the first part, whatever is there inside. So what is there? qTAN theta plus p secant theta is there. Towards the other side, what do you have? So what did I do? I squared it on both sides. Why did I do? Just I said I like to use this square identity too. Therefore, to bring that square, I have squared it on both the sides. Now if you simplify, it's cool, right? This becomes as a square plus b square plus 2ab is equal to obviously x square. Okay, so what I am doing is I am considering this total part as A, I am considering this total part as B. So I am using the formula A plus B whole square. We know A plus B whole square is nothing but A square plus B square plus 2AB. I am using that formula here. Right, I am using that formula and make it possible. So what comes under that? So if it is nothing but, shall I take it as qTAN as the A? As if it is like a square, right? I plugged in that a. Now it is b square. What is b for us? Is it p secant theta? Yes. Now to a into b. What is a? qTAN theta. And the next one, it's b. It's nothing but p secant theta. So what I am doing, I am using a plus b whole square. Now it's cool. We have applied the formula. Let's simplify. Let's bring that square inside. If you come, this square comes to q and this square comes to tan also. Therefore, q square tan square theta plus, again, the both comes to both, p square secant square theta plus, as usual, 2pq. I am writing in the order. pq tan theta into secant theta is equal to x square. So that's cool. That's cool. What did I do? I took the first quadratic, first expression what I have given, and I am squaring on both the sides, and I have applied. What's the formula? A plus b whole square, which is nothing but a square plus b square plus 2ab. I brought in the powers. I got an equation. Now let me keep it to a side, right? I like to call this as equation 3. So this is equation 1, this is equation 2. I have squared the first equation. Now I am able to get the third equation. Now what will we do? We have squared on both the sides for the equation 1. Why did we? Just to be able to use, as we are having powers in the square identity. Why? Because we are supposed to use that. Now let's get back to that. Squaring on both sides, squaring on both sides for equation 2. Yes, whatever we have done with the equation 1, let's do the same thing for equation 2 there. The same thing we are applying now. So it's nothing but whole square is equal to square. What is towards the left hand side of the equation 2? It's nothing but pTAN theta plus q secant theta. In the same way, towards this side we are having y. Okay, we are applying the same formula there, no issues. So directly I can write it as a square plus b square plus 2ab, of course, is equal to y square. This becomes a and this becomes b. Just let me plug in. pTAN theta q secant theta. Here again AB, so it's nothing but pTAN theta and this is q secant theta. Okay, now as we have done here, let's bring it in. P square tan square theta plus q square secant square theta plus 2pq tan theta into secant theta is equal to y square. Cool. So what is here? Now let me call this as equation 3. Cool. So now we are preparing our question, right? What is the thing? We have to eliminate the theta. To make it applicable to the square identity, to bring that power, I have power. See here, secant square, tan square, secant square, tan square. I'm ready with that. So what is the other logic what we thought? Let's subtract the equations. What we have? We have to subtract. We need minus tan square theta, minus tan square theta. So I got the freshly third equation and fourth equation. What's my plan? This is my plan. Subtract the equation 3 and yeah, as planned, we got the equation 3 and we got the equation 4. Now the concept is we like to use secant square theta minus tan square theta is equal to 1. That is the formula what we are planning to use. So we are ready with all the secant squares, we are ready with the tan square. What we want? Subtraction, as the logic 4 says. Now subtracting, right, subtracting equations 3 and 4. Let's subtract the equation 3 and 4. That's the logic what I am doing. So what is that? So what is the equation 3? It's nothing but, shall I call it as x square is equal to, what's that? So it's nothing but q square tan square theta plus p square secant square theta plus 2pq sin tan theta secant theta. Right, it's nothing but equation, what's that? Equation 3. Okay, now what is equation 4? What is equation 4? Y square is equal to, what is there? We have p square tan square theta plus, what's next? Q square secant square theta plus, what is here? 2pq tan theta into secant theta. These are the two equations. So what's our plan now? We are planning to subtract that. So what is the meaning of subtraction? Whatever the signs we are having in the bottom equation, let's change it. Right. So what we are having? Plus, let's change it as minus. Right. If there is no sign, it's nothing but plus, remove it and place it as minus. Now in the same way, whatever sign we have, remove that and place it as minus. Whatever sign we have, remove that and we place it as minus. That is called solving by subtraction. Now if you check it out in a cool manner, what is the thing which gets cancelled? 2pq tan theta secant theta minus 2pq tan theta secant theta. Can I cancel this? Yes, we are done with that. We are in the process of eliminating the theta. We are in the process. We have eliminated this entire stuff. Now let's work on this. What is left over here? X square minus y square is equal to, what is here? Right, q square. Right, something like q square tan square theta minus p square tan square theta. If you check it out cool, I have written here q square tan square theta minus p square tan square theta. I have written only that. Now let's come back to this. What is here? Plus p square secant square theta, right, minus q square secant square theta. Right, yes, I'm done, yes. So till here we are all set. Okay, now let's start thinking. We are processing towards this side. We don't have any thread, right? We are having threads all out here. So what's my plan is, right, what I'm doing, see here, we are having tan square theta, we are having tan square theta, secant square theta, secant square theta. My plan is, let's bring all the p squares one side and q squares to the other side. That is x square minus y square. I'm repeating, I'm bringing all the q squares at one place and I'm bringing all the p squares at one place. So if you check it out, here we have q square and here we have q square, right? So let's bring these two at one place. That is q square tan square theta. I brought it to one side. I kept there only. I brought this one to the front. I made all the q square at one place. So I'm bringing here minus q square secant square theta. I brought this one just beside this. Why not? You will get it. Now what I'm doing, p square and p square, those two I like to keep it at one place, just beside. So here it is minus, okay, let me do one thing. Let me place this one first. That's it. So that is plus p square secant square theta. What is next? Minus p square tan square theta. I think you got an idea. Why did I place that? Why? Because we are having the formula secant square theta minus tan square theta. That is the formula I'm planning to use. Okay, let me work on x square minus y square. So now if you check it out, can I take a q square as common here? Can I take a q square as common? Yes. If you take q square as common, what is left over? Tan square theta minus secant square theta. Yes. Point 1. Right. Now if you check it out here, can I take p square as common? Yes. If I take p square as common, what is left over? Secant square theta minus tan square theta. Cool. So now, are we all set to use the formula? Yes, we are all set. Secant square theta minus tan square theta is equal to 1. But we are stuck here. We don't have tan square theta minus secant square theta. We are having secant square theta minus tan square theta. Therefore, what I am doing, I am taking x minus as common there. I took minus as outside. Minus q square. I pulled out minus. If I remove minus out, this becomes plus. As it is plus, I am writing first. Okay, now if there is no one here, it is nothing but plus. Plus means minus into minus. If I remove one minus, one more minus is staying there. So as that minus is there, I am writing to the second. Okay, now we are all set to use secant square theta minus tan square theta is equal to 1. Right, I repeat, here we are fine for using secant square theta minus tan square. You are happy with that? Now we are stuck here, right? It is in the reverse order. So what I am doing, we want plus secant square theta. Therefore, I took this minus outside. Fine. So as I took minus, right, it is secant square theta I have written first, right? Now it is tan square theta. What is the sign beside it? It's plus. Plus means minus into minus. If we remove one minus as common, it is having minus sign now. As it is having minus sign, I placed it in the second place. It's cool. Right. Now straight away, x square minus y square is equal to minus q square into this total is nothing but 1 plus q square and this total is nothing but 1. How did you get that? That is what the logic now. By square identity 2. What is that one? Secant square theta minus tan square theta is equal. This is what we are using for. Now let's simplify. We are all done. X square minus y square is equal to minus q square plus p square. I am shifting the places. X square plus y square is equal to p square minus q square. So we got an expression where we don't have the theta. We have eliminated the theta at the last by using the square identity. Secant square theta minus tan square theta is equal to 1. Hope you understand. In this channel, I have been placing both math and science videos.